Hello and welcome to the 57th part in this series for beginners programming in C. So in this video I've already started with a little program here which should be very familiar. The only thing that might not be familiar is the headers that I've got in preparation above. So I've got the standard in-out, I've got the standard library because that's containing some functions we'll be using inside this video. String.h, you'll know why it's there because we're using strncmp here. And limits.h, which I'll also be explaining later in the video. So what this program does at the moment, it's a very bad programming practice infinite while loop here. Obviously while non-zero, so 1 is always non-zero, it keeps looping, and it basically takes input, which should be a number from the user, stores it in our character buffer, reading in up to 31 characters, and if the user types quit, then we break out of the loop. And what I want to do is one of the most simple requested things always when programming in C is how do you convert some input, maybe you're reading a database from a text file in or something like that. How do you convert the characters easily and quickly into an integer? Well, some functions to do that very quickly and easily provided in the standard library. But the reason I wanted really specifically to have a look at it is because there are some bad gotchas with those functions that cause bugs, bad bugs in people's programs. So I'm just going to make some variables here, and I should call that one our float, where we're going to store our values. So we've got an integer, our int, a long, our long, a float, our float, except I've called it out float, and a double which we're going to call our double, like so. And what we're going to do is take the input from the user in this case, and try and store that input into these numbers. So in a similar way to how we used scanf, but much quicker and much simpler. So using the functions that are inside the stdlib, the standard library, all we have to actually do is say that our int is equal to a to I, so character to integer, and of our input. And that's all we need to do. Our int will now be containing the integer conversion of the characters entered by the user. For our long and our float and our double we have the same thing, except a long is a to L and a float is a to F, and a double is an a to F and a float is a to F. And now what remains is to print these to the screen. So we say our int, like so, and I'm going to be really lazy and just copy these again below for a couple of rows. So 1, 2, 3, and thank you for tabbing. Let's take the long, the double, and last but not least the float. And that should be like so. We have the percentage %d for a decimal, the LD for our long, percentage %f for the double and the float. So now our program's actually complete. That's all we really need, apart from one tiny little thing we'll be adding in a bit with the limits. We can compile the program and run it. So let's enter 1, 2, 3, and now you see our functions have worked. Our integers are 1, 2, 3, the long, the double, and the float. Let's enter something a bit bigger, and things have been read in again okay. Now let's have a look at the first gotcha. Let me enter a character and then a number, and you'll see that all of them here are returning 0. And this is the first problem and thing you need to bear in mind when you're using these functions. It may well be if you're reading in a database of values you're expecting just numbers, and that in fact there's an error if you come across any characters, or certainly in this format say. But these functions here, the a to I, a to L and a to F, return 0 upon error. So it's quite problematic actually. You're wanting a number from these functions and they give you a number, even in the case of an error. They don't give an error code back or anything like that. They simply give you a number. So you need to make sure you bear this in mind if you're using these functions in your programs, that the input could still not be as you were expecting, but you'll get a number back from these programs. And indeed in my chess program when I first ever started, about 12 years ago, I had some bad bugs by using a to I for this reason. If we do it the other way around and type, let's say 35e, we read in 35, and again the same principles apply. You have to bear in mind the behavior of these functions and make sure that this would be an acceptable input to read in the number 35. And things actually get a little bit worse from there. I've said at the beginning of the video I'm not going to explain all of the reasons why, just show you where the problems can occur. It's up to you to look them up. But let's put in something like 100.3 and think about what you might expect here. We have from our integer 100, our long 100, our double 100.3, but you'll see that our float has 100.30003, and you might be wondering why that's happening. Let me put 100.01 in, and now you see that we've got 01002 in this way. And in fact, if I put in something like 30.01, we now get 30.01000 like this. I'm just having a quick look back at the program. So the question would be, why is this occurring? Because the float number that we're getting out of this is incorrect. Well, what's actually happening here is there are two different things happening with the double and the float. The float, what happens is in the conversion, in very simple terms, is it's trying to fill all of the bits available to most accurately represent the number from the characters it's trying to convert. So each time you see the number here, it'll be, in some cases, giving you extraneous decimal places to, in the binary representation, get as close to 100.3 as it can. And that's all I'm going to say on that, because that raises more questions than answers. And to be honest, the best thing you can look at is floating point precision conversion in Google, and you'll come up with some very long detailed explanations of binary representations of floating point numbers. The double, on the other hand, does give you the representation, and again, read up on it on Google. It's not for this series, this video, but the thing you should bear in mind in this series is that you will get this behavior, so you need to make sure that you allow for this kind of behavior in your program, and that will probably lead you to choose either to use a double or a float depending on the circumstance. This, however, isn't the only problem that we have when reading in the numbers. Let me now put this rather large number in and see that it's read in correctly as an integer long and a double. It's not read in correctly in the float. And if I just take this large number now and make this a 50, you'll now see that our integer has read this in incorrectly, and our float, as before, has also read this in incorrectly. And you might be wondering what the reason is for this. Well, the reason is it's a 64-bit computer, this, so we've got, for an unsigned integer, 2 to the power 63 2 to the power 31 plus or minus, and this 2147, etc., etc. number is actually exceeding the limits of an integer on this computer. And when you exceed the limits, you start getting incorrect values, and the same is applying to the float here. So again, I'm not going to go into the details of why or how you get this representation, but the point to remember is if you're using A to I, you need to be absolutely sure that the values that's being entered or read in are inside the limits for an integer. Now if I just quit out of this and go back into our program here, we can actually see, or you can actually see on your computer, what these limits are. So if I'm just going to copy this long and int here, because they're the two important ones. The value, you can ask the compiler what the values are by simply using a macro called int max. And this will tell you the maximum value, plus or minus, you're allowed for an integer. And you can also look up long max for your specific operating over your specific system in the same way. And in fact, on C++.com, there is a huge table here with the macro constants, the sizes, but of course that is based in this case on a 32-bit computer, not a 64-bit computer, and you can read about these limits inside here a bit further. So if I now just bring across the terminal again and go to compile the program and now run the program, and now you'll see it's given us our long max and our int max, and this int max is the number I was using, and when I went above this number it gave us problems. If I take the long max and do the same thing, int has given up completely, long has managed to read this in, but now the double's starting to have problems, and the float is starting to have problems. And in fact, if I now go above here and just type 900, you'll see that they actually restrict themselves to the maximum value available in case of the long. The double and the float are these numbers, and again, for this video, suffice to know that they're just incorrect. They're not the numbers that were expected to be read in, because they're exceeding the limits available. So what you can see here is, through a bit of a long-winded explanation in this video for a relatively simple program, is that it's tempting in your programs to use these functions to quickly read in integers or whatever, but you do get, depending on the input, unexpected behavior that you might not want. They do give you a value back, even if what they're getting in is invalid, so exceeds the limits or doesn't contain numbers or something like this. Bear in mind, please, that these functions give you something back. But so long as you're sure that the values are within the limits that you expect, then obviously they are fine to use and a very simple solution to converting characters into numbers. So that's it for this video then. Again, I apologise for the lack of explanation on what's going on float and doubles in the case of exceeding the long, but I suggest if you're really interested in that, you read that on Google, because the explanations are very long about how decimal numbers are represented in binary. So thanks for watching. Comments, questions, criticisms welcome as always on YouTube.